Hi class, today we have the 12th lesson for sequence and series EP and GP. The question we have today is a proof that if the pth term of an AP is Q and the qth term is P, show that the P plus qth term is 0. Alright, we are told that the pth term is Q and the qth term is P. So just like the inverse or the reverse, sorry. The pth term is Q, the qth term is P. In sequence and series AP and GP, if we want to say ninth term, we use this way to represent it. So this is ninth term. Yeah. So if we want to say the 20th term, we say T subscript 20. So if it says the pth term, so T subscript P, and this pth term is Q, and the qth term is P. But finally, we have to show that the P plus qth term, meaning this one, the P plus qth term, whenever you are discussing a cardinal number, you have to make it like this to represent a term. Yeah, show that the P plus qth term is what? Is 0. So this is what they want us to show. All right. But do not forget that we have AP and GP. And here specifically, it is an AP. So what we do is, the P term is Q, the Q term is P. But generally, the nth term, when we say nth term, we mean the general term. Yeah, the general term. The nth term for AP is A plus N minus 1 multiplied by D. This is the general term. Now, if this is the general term, so observe here, nth term, N. So if we have like let me say the 6th term, 6 here, the 20th term, 20, the pth term, P, the qth term, Q. So we need to understand this. So now let's go for pth term. The pth term is A plus, we no longer use N. It was N because of N term. Now it is pth term. So P minus 1. And here is D. And this pth term we have is what is given as Q. So we say equal to Q. I hope it is clear. All right. So this is our equation 1. We go again. The qth term is A plus. Are we using P again? No. Are we using N? No, we are dealing with the Q term. So now we say Q minus 1 multiplied by D. Where this one is coming from the general term, which we call the nth term. So this qth term is given as P. So this is our second equation. All right. So, but here, let us understand that. Okay, let me do label here. Okay. Now, let us avoid this one here, this face. So now we can say A plus P minus 1 D equal to Q. This is equation 1. So we say A plus Q minus 1 times D equal to P. This is equation 2. Okay. So what do we want? We want the P plus Q term. But we want to show that the P plus Q term is 0. All right. So what we do here is, let us try to reduce this one here first. If we say P minus Q, or sorry, if we say P plus Q, the A and A will still survive, because saying this plus this equation plus this equation, this and 2 will be added and A will be added. But if we say minus, the A will disappear. So that will help us to reduce what? Um, more terms, to reduce more terms. So now what we say is, since let's just obey the alphabetical order here, though it's not compulsory, by aiming at P minus Q. All right. You may ask, why not P plus? I'm not saying it is wrong to say P plus, but saying P plus, all terms, all values, or yeah, terms would still appear. But if we say P minus, this and A will vanish, the A will vanish. So now we say equation 2 minus equation 1. So whenever you are adding or subtracting or you are multiplying or you are dividing two equations, the left and the left work, the right and the right work, whether you are adding, subtracting, multiplying or dividing. So since we are subtracting 2 minus 1, the left subtract themselves, the right subtract themselves. But don't forget 2 minus 1. So 2 minus 1. So on the left, here is A plus Q minus 1 times D. Yeah, the left minus the left. But don't forget 2 minus 1 minus, yeah, the same left, which is A plus P minus 1 times D. Equation 2 minus equation 1. We are done with the left minus the left. Let us go to, because we have equal to the right minus the right. That is P minus Q. So here is A plus Q minus 1 times D. This interferes here minus A. This interferes here minus P minus 1 times D, which is equal to P minus Q. What I was trying to talk about, now you can see this go away. So leaving what? Q minus 1 times D minus P minus 1 times D, which is P minus Q. All right, so if we think we can further what? We can further simplify, no problem. So let me write this one first. P minus Q. The reason, because one thing about mathematics, it's not like we are doing magic. It's not like we are moving blindly. Sometimes, because this one is very important, this one I'm explaining. Yeah, you might be thinking that, come to think of it, why he decided to stop here? Why he decided to even get to this level? Why he decided to even go one more step before quitting or before go to another one? Well, the thing is that you can even choose to stop here and try to find the expression for P plus Q, the P plus Q term. But the thing is, sometimes if you don't simplify certain expressions or certain equations um, to reduce the number of terms, so even if you get to some point, when you come again, you'll have to do the same. So you can even choose to stop here and try to find out first what is going to be the P plus Q term. Yes. So let's just try to simplify this and see what happens. Now I write this one. What I'm trying to do is A equal to B. I can choose to write B first equal to A. So I am writing this before this side. So I have written the right hand side. Now coming to the left hand side. When you come to the left hand side, this term and this term, they have something in common. What? D. So see what I'm doing. I'm writing that D outside. This term and this term, they have what? They have D that is common. There is D, there is D. So if this D takes away this D, what happens? Q minus 1. Do not forget there is minus. If this D takes away this D, what happens? We have P minus 1. This bracket closes this. Here is our D. I hope you understand my point. Okay, so our target is the P plus Q term must be 0. Okay. Oh, sorry, I did not mean to, because this one did not mean to indicate this one in bracket. So P minus Q equal to, yes, this outside in the bracket, Q minus 1 minus interferes minus P minus times minus plus 1 outside D. So what happens? P minus Q equal to 1 minus 1 plus 1 go away. So we have what? Q minus P times D. Do you see that? Okay. So with this one we have, what happens? They look alike, you can see. P minus Q, Q minus P. Only that the letters are in the opposite. They are not exactly the same, mind you, because P is positive, P is negative, Q negative, Q positive. So what do we do here? We can invite a minus sign. Say minus. With the minus that we invited, whenever you invite a minus to a particular expression, every sign of the sign of every term has to change. So this plus becomes minus P. This minus becomes plus Q. So this one that we've done, nothing is wrong. Absolutely. Why? Because minus times minus is plus P. Minus times plus minus Q. See? So this is Q minus P times D. So now Q positive, P negative, P negative. We need D here. So Q minus P, Q minus P. So D is this and this will go because Q positive, P negative, negative. So it remains minus 1. There is this point I still want to explain. How do you know that you will get to this? It doesn't mean that it's something that you are preoccupied, like saying, well, I know I'm coming to this level. Once you think it is possible to simplify further, just keep doing that because that will later help you, especially a case where you are trying to prove something. Okay, now we are here. Now let's go to what actually we are aiming at to find. Yes. What is the target? The target is we want to show that the P plus Q term must be 0. Can we write that 0 now? No, because we need to show that. We want to show that the P plus Q term is, but according to the general term for AP, the n term is this one. Whatsoever used to replace this n, you can also use this to replace this. When it was P, this n changes to P. Q, this n changes to Q. Now it is P plus Q. So this n again will change to P plus Q. So now we go A plus, what is n? N is now P plus Q. Yes, then we have minus 1 times D. Do you see that? All right. So this is equal to A plus P plus Q minus 1 times D. But D is now minus 1. This is exactly the point I was talking about. Assuming we stopped somewhere here, once you know you can simplify, you can take it to the simplest form. Try by all possible means to do so. Okay, so this is A plus, yes, this minus 1 is now affecting this to become minus P. This minus 1 affects this to become minus Q. It affects this to become plus 1. So A plus times minus is now minus P with this minus Q with this plus 1. This is what we have. So as it stands now, we have not shown that the P plus Q term is 0 because this is not 0. So as I was saying, we need to go somewhere and create something that will come and help us here. Yes, that is what exactly we must do. So what we do is we have P, we have Q. Yes, we have P, we have Q. We have Q expression, we have an expression for P. So let us go to one of these two. Yes, we can choose to go to Q, we can choose to go to P. Because the question is show that the P plus Q term is 0, and as it stands, it is not 0, despite we've substituted this D, not 0. So what do? Let's go to one of them. So let's decide any of them. So we can say from equation 2. But let us label this one here. Um, when we label, some people get confused when you label equation or an expression. Just that when you need it later, you will not struggle to get it. Yeah, you can even choose to not to identify it. It doesn't mean anything. Once you know, you can find it later. Now from equation 2, 2 says P is equal to this one, A plus Q minus 1 times D. Q minus 1 times D. So say P is equal to A plus Q minus 1 times D. What is D? D is minus 1. I hope you are following. If you are interested in copying, pause the video, then you can copy. All right. So let's see the simplification of that one. We have A. Of course, P plus will not affect any, will not change any sign. Minus 1 times Q, minus Q. Minus 1 times minus 1, plus 1. All right. So see what we have here. See what we have here. See, this is what we have. The target is the P plus Q term must be 0. This is the point. So here we have A minus P. Can we generate A minus P? If you want, you can formulate A minus P and bring it. If you want, you can formulate A minus Q and bring it. Yeah. But A minus Q, look at A minus Q. A minus Q. Do you see that? So let's move this one here. This one comes here. So we say P minus 1 equal to A minus Q. Do you see that? So for just the A minus Q is now this one. So now we say, therefore, P, the P plus Q term, which is now this, A minus P minus Q plus 1. Yeah, let's just bring them closer. Look at this one. So we say A minus Q. Do you see that? So now we say minus P plus 1. I hope you are getting it. All right. So now we say, what is A minus Q? A minus Q is P minus 1. What is A minus Q? A minus Q is P minus 1. So for this A minus Q, it is now P minus 1. Then we continue minus P plus 1. So therefore, P minus P, 1 minus 1 is 0. So this shows that the P plus Q term is now 0. I hope it is clear. So thank you for watching. Do not forget to follow, like, share, and comment. Also subscribe to the YouTube channel.